So good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss on a worksheet on current electricity. So let's begin with things. So the first thing is drift velocity. So drift velocity is the average velocity with which all electrons can be assumed to move. The concept of drift arises from the fact that if we observe closely the flow of electrons in a particular conductor, for example, take a copper wire and feel that how electrons move in that copper wire. So copper wire is a conductor, so it is comprising of a large number of electrons which are free to move within the wire itself. So what happens is that these electrons collides with each other, and it's very complex system to analyze uh, each electron. So if we see the result of these electrons, then if we assume that all the electrons move with a constant drift velocity opposite to the electric field, then we have a simpler system. We can analyze it in a better way, and it produces the same impact as that of analysis of the complex system of intermolecular forces, or you can say that the internal forces between the electrons, their collision with atoms and electrons. So to bypass that, we use the concept of drift velocity, and drift velocity is dependent on electric field. It's actually opposite to the electric field, and it's given by minus E by m into tau. V is 1.6 10 raised to power minus 19. So this is the concept of drift velocity. Now comes the concept of resistivity. So resistivity is equal to m upon n square tau, where m is mass of electron, n is number density of electron, is electronic charge, and tau is the average relaxation time, which is time interval between successive collision of electrons. So these are the simple results, and you should retain them as they are being asked multiple times in the question exam. So this is the thing. Next is effect of temperature on resistivity for conductors. So as you can see that resistivity is inversely proportional to tau, which is the average relaxation time. So if we increase the temperature, then average velocity of electrons increases, because of which tau decreases. They'll collide faster, the collision frequency will increase. As an impact of that, time period or the relaxation time will decrease, and as an impact of that, resistivity will increase. Whereas in case of insulators, here number density and torque both comes into play, because for conductors number density is approximately constant, so there is only dependency on torque. But for insulators, N as well as torque, there is a dependency on both of these factors. So on increasing temperature, N increases and torque decreases. But it has been experimentally observed that the product of N and torque, this product increases as a whole, because of which resistivity decreases. So that is explanation. It has been verified experimentally by doing experiments on insulators and semiconductors, that with increase in temperature the resistivity decreases for insulators as well as for semiconductors. So these facts are well established at experimental level, and this is just the empirical formula that comes after a lot of analysis, experiments, and a lot of debates and speeches and all that. So after satisfying everybody, the laws have been established by experimental facts, and this is the analysis of these laws. What's the theory behind this? Now there is another concept: what is effect on temperature or number density of free electrons? So there is no effect, no charge, because most of the electrons are generally free. The outermost electrons. That is the case for this. Next is effect of temperature on number density for insulators. Here is the key. Insulators have very small free number of electrons. So with increase in temperature, the number density increases. This is the same case for semiconductors also, that with increase in temperature, number density increases. So same case will happen to both. Now is the concept of ohmic conductors. So certainly ohmic conductors are those which follows Ohm's law, for which V is equals to IR and the graph is a straight line. So that is a concept of ohmic conductor. Now there are certain non-ohmic conductors, that means which does not follow Ohm's law, or whose resistance is not constant but is a function of voltage or current. For example, if we have diodes, transistors, or even gallium arsenide, then if we draw the VI graph for these uh, elements, for these, you can say that devices, then it's not a straight line, it's a curved one, and even resistance may be positive, negative, or zero as per gallium arsenide is concerned. So this is they follow non-ohmic laws, or non-ohmic conductors. These are non-ohmic conductors, you can say. Next is, I think it should be more precise to name them as ohmic devices, because it's not necessary that they should be conductors. So in general, we can name them as ohmic devices, and because they can be semiconductors also. Devices should be the more general word, but sometimes conductor word is also used, so you can relate to that also. Now next is, what is Ohm's law? So Ohm's law is V is equals to IR. The voltage or the current produced in a conductor, ohmic conductor, is proportional to the inversely proportional to the resistance, and from there we get V is equals to IR. Larger the voltage across a given element, larger is the current across that, given that resistance is constant. So resistance is constant in Ohm's law. Although there exist elements for which resistance is variable, and increasing voltage may have negative impact on the flow of current also. So as per gallium arsenide is concerned, so resistance may be positive, negative, or zero for that. So for Ohm's law, resistance is constant. That is the basic assumption, which makes them ohmic resistors. I think resistor should be the correct word. And in general, ohmic conductors, non-ohmic conductors also exist, or non-ohmic resistors also exist, for which resistance is not constant. So as per Ohm's law is concerned, resistance has to be constant. Next question is variation of resistance with temperature. So experimentally it has been found that if temperature is T naught and resistance is R naught, then at temperature T, RT is equals to R naught, 1 plus alpha T minus T naught. This is for linear ohmic resistors, which follows a linear relationship between temperatures. Although it may change, but generally we can say that for the linear resistors, this case holds good. Then is another question, that what is alpha? So alpha is called temperature coefficient of resistance. It may be negative or positive, and even maybe zero for certain, for certain alloys like nichrome or constantan. So it is positive for conductors and negative for insulators and semiconductors, while it may also be zero for some alloys like nichrome, constantan, etc., which finds use in electrical circuits for which resistance should be constant. As if resistance will increase with time, then it will affect the current in the circuit, the power in the circuit, or the characteristics of the electrical circuit. So if we use constantan or nichrome wire, then resistance will be constant over a considerable range of temperature. So that keeps on, that can give us desired output in terms of power or current for a certain range of temperature. So that's why um, these wires are significant. Next question here is effect of temperature on torque for conductors. So as I already discussed, torque decreases in all the three cases, because with increase in temperature, electron starts moving faster. There is a collision frequency increases. They collide faster, and because of that, the average relaxation time decreases. Then we have the concept of alpha equivalent for a series combination. So suppose there are two resistances R1, R2, coefficient of thermal expansion, temperature coefficient of resistance alpha 1, alpha 2. Then for a series combination, we can derive that under the assumption that alpha is very small, that alpha equivalent for series combination will be alpha 1 R1 plus alpha 2 R2 by R1 plus R2. Whereas in parallel combination, just reverse the case, it will be alpha 1 R2 plus alpha 2 R1 by R1 plus R2. So you have seen that we have solved uh, 18 questions in a video of, let's say, 10 minutes. So these worksheets are designed to optimize your time and energy. It's also cross-checking mechanism for you. So if you are able to manage more than 80% question in the first sitting within 10 minutes, then you are doing good. But if you are not able to manage, then you just need to work on your process of learning, So if you have any doubt, you can ask in the comment section. Thank you and have a nice day.